Okay, I've got the tow booth. Now this is the circuit. This is what it looks like. And over here, I'm actually utilizing the buttons on the microchip. So that would be these guys right here, button 0 and button 1. Right there, those buttons are going to be utilized. And then I used pin 8 and pin 2. And those are where the blue and purple wires are. Sorry, nope, misspoke. That's where the gray and purple wires are. So pin 2 is gray and pin 8 is purple. Pin 14 is the clock, that's blue. Okay, so you can see that. And then over here are my PIOs, so my outputs. So I have 22 and 23, so I'll show you those quick. So 22 and 23 are the green and yellow. I don't want to move too much stuff. So green and yellow are 22, 23. Green is 22. That goes to my driver chip. That's that thing there. And then 23 is the yellow wire right there. And that also goes to the driver, you can see. And then 24 is actually power. I actually powered the chip without this. So you're gonna do that. That's what this ground wire is here. This actually powers the chip. So before you even plug this in, once you get this, once you get the power supply turned on, it'll power this chip up, believe it or not. So it has separate power. So the cable's only utilized for uploading your program, which is this thing here. So I've gone over the PIOs. There's 14, FYI, that's your clock. It's a 2-bit system, okay? So the other thing that you have to wire to this little driver chip here is the power supply. So the power supply is here, and that has to be set to 6 volts, okay? The ground wire just simply goes to ground, so blue in this case, and then the power wire goes over to the corner here. So I'm kind of wiggling that so you can see that that's where that goes. Oh, lovely, let's get interrupted.
Olivia and Nevaeh Jones Patterson to the front.
The only 2 wires that you see that are outputting from the driver are these 2 blue wires here. So the one of them is a stripe, but they're both blue. And then they come down here and they're just kind of randomly plugged in. And then that wire actually goes over here and is gonna power our motor. Okay, and this powers the actual arm. Now there's 2 limit switches. There's an upper limit switch, which I've been messing with and bending, trying to get it to work right. And then there's a lower limit switch here. So you can see that one, and that's where the arm will hit it to stop. So the way this thing works is that when you push one of these buttons, it goes up. And when you push the other button, it goes down. So I think I actually might have it reversed, but I'm not entirely sure. It does work. Right now we also have a red light on. And the reason the red light is on is because the gate is down. So that would mean the car needs to stop. And that red light comes off of, let's see here, comes off of this particular plug right here, the left plug, which goes to my lower limit switch. That's lower limit switch. This is the upper limit switch here, okay? And that actually, that wire is going to the green light. So what's gonna happen is when the gate goes up and it hits this limit switch here, the green light should turn on, ideally. So let's see what happens here. We'll get way back. Okay. And there you go. So the gate went up, hit the limit switch, stopped, and you get a green light saying to go through. So that's good. So far, so good. And then what's gonna happen is when I lower the gate, so this button, the one on the left, it should go down and red light. And there you go. So that's how it's supposed to work. Now within all of this, there actually are resistors that have to be utilized. So you can see there are 4 resistors here. Okay, I actually have 100,000, so 100K. You can use 10K also. I tried both. So it shows 100K in the schematic, but the picture shows 10. So I used both. And then this is a 330 and then a 180 here. And all of that is shown on a picture. So if we look at the screen quick, everybody's gonna get this and you'll have to kind of follow this. Now, obviously my wiring doesn't look anything like theirs. And they do not have the traffic light in here. But it's pretty much the same thing. Pretty much the same thing, except we're not wiring it on that crappy digital board. We're actually gonna use the nice heavy duty, bigger ones. It gives us more space. And biggest issue is I had to like put this on a coffee can because the wires are too short. So we're gonna have to figure that out too, how to elevate this properly, because this is actually hanging off the edge and I hate it. But there it is, that's what it's supposed to look like. So you're gonna get this picture, and I'm kind of debating. I think I'm probably gonna share this file with everybody, just kind of make things easy, and then really you'll all be responsible for getting it to work. Also, normally we use DIO3 and it wasn't working. It was very, very slow. I'd pushed the button a million times. That's because the clock signal was too slow. So I went to 1. You can see that there. And all my power, all my 5-volt power comes from here. That is the origination. So you have the 5-volt and ground hooked up, and then that goes from here, and then it actually crosses over and goes down to this one also. So that also has power as well. And then the 6-volt power goes directly from the power supply into the chip, into that driver chip there. So 6-volt will not go anywhere other than to the motor. It is not to go anywhere else, in fact. So yeah, so there it is. Finally made a video, and I can see how I did it, which is awesome. And this, of course, is just for power supply. This is just for uploading. It's not going to power our chip for this activity. And yeah, I'm pretty pleased with that. And I will actually save it this time. And there it is, green light. Gate is up, and then gate down. And red light on. And sometimes it does that, so that's good. So what it did was it went too far. I don't know why. And the limit switch sent the signal too late, and so it went past that. No big deal. You're just gonna readjust it a little bit, and it should be okay. As long as the limit switch stays pushed down, should be good to go. But be aware that could happen. Okay. Cool.